actually focused on. Now, this is more like a heat map of the things that we had. From a timeline perspective, like you all know, we have developer previews, then beta releases, and then the final release. And that's been the way we have released Android in the past many releases. The thing I want to call out here is that we are out of developer preview right now. We are close to we are in beta 2, and the whole idea of doing this approach is that during developer preview phase, it's for developers to try out things and see how this works on for their applications. What are the new changes? How these changes will affect their application. This is a phase where you guys should analyze the changes and try and give feedback. One of the things our region is really low at doing is sharing feedback. If I go and ask a developer, what do you think about Android 11? There are 10 comments towards it, and they're all very valid, thought through sort of answers that I get. But then when we look at the stats, nobody would actually communicate that or share their experience with the team. So that is an area where I think all of you guys can actually improve. It's not like you're talking to a wall. We do take, we might not be able to acknowledge every feedback that comes to us or every mail that comes to us, but we do take all that into account. And during developer preview phases, there are a lot of changes that are made in the OS to kind of better cater to the use cases in the real world. Because as engineers, the team which is actually building these features will actually make assumptions, might not know every condition under which a feature gets used or how a feature is getting used. So real world feedback really helps us fine tune things. So a lot of features actually get changed during this time. So during developer preview, one of the things I really want to call out is don't go ahead and jump ahead and start changing your code, because API contracts, the behavior can all change during this phase. This is for you to analyze what the new features will be, what is the direction of the new features, and if any of them is actually going to affect your apps. During a beta phase, that would be the best time when you want to kind of go ahead and start thinking of what changes you want to make to your application to adhere to the new guidelines or to implement new features in your application. Because by beta, most of the APIs are going to be stable. There will be very minimal changes in the beta phase that happens. It's more of stabilization that comes in, and platform stability comes halfway through beta, and then we proceed towards a final release. So the thing to call out, reiterating what I said, during developer preview, please do test your applications, understand the changes, and understand and identify the areas where you need to change. It would be advisable not to jump in and change those things, but wait for the beta where the API contracts as well as the behavior is kind of finalized, and then start making the changes. And before the final release, ensure that your app is compatible, because the most early adopters will actually adopt the OS for your app, would most probably adopt the OS also faster, and you don't want them to have a bad experience. It is not like if a bunch of your most vocal users are actually moving to the latest version of Android and then your app crashes there. That would lead to a bad experience, and that's what you want to avoid. And there's enough time. So Feb to nearly third quarter is enough time for teams to make these changes incrementally. And another thing that I would say definitely for people to plan is don't make all the changes one shot. I understand that most teams make these changes in multiple sprints. They have multiple sprints in, say, if you take somewhere from May to Q3, end of Q3 or mid Q3, there are multiple sprints that everybody would be doing. Make your changes go in each of these sprints incrementally, so that you don't have to make one really large change towards the end where stabilization of your app becomes a real tricky point to be. And you might want to roll back, you might have to roll back and things like that just to keep the stability back in. That is again another recommendation that we generally give, so that developers have enough time to roll out incrementally, and maybe enable the feature later, that's fine. But you want to test in real world the stability of your changes as well as how users are reacting to it. You don't want one huge change going in and having some effects which you're not sure, you're not able to track back to which feature or why, if there's a negative impact, why that has happened for you. Yeah, this is basically what I meant earlier. So review the program timeline, set up an environment. That's really important during developer preview. Please set up an environment. Sometimes you might not have the device for which we release the OS. for you to set up, but emulators will be available during that time. Go to the new studio setup, ensure that you use the new tools, understand, because the SDK, it is much easier to go through the SDK and documentation if you have studio. As a developer, if you have studio installed, that will be a much easier way to do things. And learn about the features, changes in behavior, and test your app. That's basically what you should be doing during the developer preview. Moving on, let's start with the privacy changes in Android 11. So there were many things that we considered. In Android 10 itself, privacy was something that we took as a really core area to improve, especially for users' data. As well as privacy. We took a really strong approach towards it, and there were many areas on Android, existing things that were changed, and there were also new things that were introduced. Things like location control. Location control was already there, but we tightened it up. Whereas like completely new things were introduced, like one-time permission. Those were completely new features. So all these privacy changes are a collection of changes to the existing behavior, as well as some new features which you can take advantage of to provide better experience to the users. Having said that, some of this new behavior can be more restrictive too. So you really need to kind of look at that part and understand and ensure your users are easing into the flow, rather than suddenly coming in and having a negative experience on your platform because you just moved too quickly or jumped to use the feature too quickly without training your users. Now let's start with scope storage. Scope storage was something that we introduced in Android 10. But during Android 10, during the developer preview phase, we got a lot of feedback saying that there was not enough time to kind of adjust to all the changes that were there. So we introduced a flag called as request legacy external storage, which allowed you to put this flag in your manifest and make the system behave exactly like in Android 9 without applying the scope storage changes. If you take scope storage, for instance, like you could take an app's memory. App has an internal storage as well as external storage. Scope storage really works on the external part of it. The external storage is divided into two parts. One is where the app, the files that app would create, and then there are things which are common. Till Android 9, the behavior was that if the user gives the permission to read files on an external storage, the app will have access to all the files in external storage. There was no restriction on what files you can read and what files you cannot. And that created some confusion, that created a privacy concern, because a lot of apps were actually using transitive data. Like, okay, if this folder is there, maybe there is a this application is installed. So using the external storage and the files within the external storage, people were trying to understand what is more data than what they were expected to get from reading a file. And there was a lot of misuse of this. And in scope storage, what we've introduced is, in scope storage, an app can only access the files that it has created. And there is also things like media files, and the rest of the files, if we consider, can be divided into two buckets. One is a media file, and the other one is basically all your other files. Could be documents, PDFs, and other stuff. So media files like audio files, photos, video, what we do is we have these gated area behind the media permission. So when somebody wants to access a photo which is captured by the camera app, the photo, if added to the media store and the user has given the permission to access the media store, the user can go, the app can go ahead and read the file. So and make edits to the file. There is multiple change. So this allows us to kind of give gated permission gated media stores to which apps can go and pick information which are media files. For any other file, you would have to use the system picker. The impact for a regular app which has file handling in it would be that if the app is using a third-party file picker, you need to test to ensure that the scope storage is not breaking. The third-party library is updated, and scope storage restrictions are not restricting the functionality of your application. So please go ahead and check. Most people have used third-party libraries for file operations and things like file operations and things like picking file picking and things like that, the recommendation is to use file picker, the system file picker, and not to use the a third party one. And third party ones, if used, they have to kind of ensure that they work with these restrictions. That makes it tricky. So please go ahead and test this if you're using that in your application. The next one is there are some areas where files need to be accessed. All the files need to be accessed. Say something like a file manager. If there's a third-party file manager that you're building, then you need access to all the files, right? Same as the case with the backup and restore file. It needs to access files which are created by other applications without the users interacting with it. Another one is antivirus. For all these sort of things, there is a new access permission, special access to it, which will allow all the files to be accessed. But again, for you to access this, there is a play policy that is guarding this. That is, you will have to adhere by that guideline to ensure that your app gets this permission. Now, this is being worked on right now. You will receive communication about it very soon. And you should ensure that your app needs that full file access as for a primary use case. It can't be a secondary use case. For example, if you have an app whose say job is basically to show a gallery, which only needs to look at the media store, photos media store, or the gated area, you don't need all the file access. But then by adding a secondary feature of a file browser, you will not get this. Play policy will not approve this. So you need to read that policy very carefully and ensure that your app has a primary reason. Otherwise, let the users choose to give you access to the file explicitly. Now, one-time permission is another one which is introduced newly. With one-time permission, what happens is you can actually provide permission for an app for a particular feature like camera or location to give it only for that one session. So a session can be considered to be when the app is in the foreground, as long as the app is in the foreground, or as long as a foreground service is running. In both these conditions, you still hold the permission. The moment the app goes to the background and there are no foreground permissions with location permission, location-based foreground service, then you will lose the permission. The next time somebody requests for this permission, the dialog will come up again, and the user has a choice to kind of do this, give this or deny it again. Two things to note here. One, you need to educate your users that each time they might have to give this permission, and you will have to identify use cases where you don't want this permission throughout. There are instances where people have a sign-up process which basically has as the location permission or the camera permission. And for a subsequent use case where the camera permission needed, they are not really checking for it because earlier that permission would anyway be given to reach that point. In this case, it might be tricky. You will not, if it's a one-time access and the user has come back to a different session, then the user will not get that permission in the second use case. So you got to check that. The second thing is deny has a slight change in behavior. When the user clicks deny multiple times, then it is considered to be deny and don't ask. So if the user is refusing to give you the permission for a few times, your app will not be able to show up the dialog and ask the user for it again. So this is something that you've got to be careful. You want to kind of ensure that these cases are considered when you're making you are actually working with this change. And there is also another interesting thing, which is auto reset permission. So if your app is something that if a lot of people install a lot of apps, but some of the things then the stats say that about 60% of these apps are not used very regularly. People might install and forget about it. But because when they install and they use it for the first time, they give all the permissions. From then on, the app has all that permission throughout. Now with Android 11, another big feature that is coming in is that it will actually reset the permissions of apps which are not regularly used. So if you install, uh, say, a new gallery, a new, say, file manager, give it some permissions, and then you do not use it for many months. When you go back to the application, you'll see that the application no longer has those permissions, and all the permission requests will start coming back again. And this will affect only apps that are actually targeting Android 11, but that will be the case. Uh, if not today, it will be what then with the next play minimum level SDK, which is coming in next year. All the apps will have to adhere to this. So apps which are installed and get the permission one time doesn't mean that you always have this permission. So you have to understand that you have to check for permission for more rigorously, not assume that you have permissions for all the things when approved upfront. There are applications which might be just for services that are running. They don't come into the UI as much. And for such things, there is a new setting for you to toggle the auto reset for a particular app. So you can go to settings application details, settings screen is where you need to go in. And then you can actually make sure that that reset process doesn't happen for that app. And this is something that you can actually code into your system if it is necessary. Now with foreground, if you remember, foreground services have different types that were introduced in Android 10. Apps can declare those permissions and then only get access to those sensors or data. Say, for example, if you wanted location, you had to declare the foreground service type as location. Otherwise, when the service requests for location, it used to get null. Even if the Fuse location provider has the data, it will not. The service will not get that. Now there were other types for foreground services also declared in Android 10. Now in 11 we have two more things: microphone as well as camera. Microphone, I've not seen many cases where foreground services needed continuously. But with respect to camera, I have seen some people using the foreground service to kind of cold start the camera library and ensure that everything is loaded into memory and things like that. Some of those use cases will be affected because if you don't declare the foreground services to be to have a camera intent, the issue that will come across is that from the camera sensor, no data will come to your service. So, and the service will not crash. That is another thing. Your services will not crash, but it will not get any data. And that is not the intent of running the service, right? So you want to run your add test cases to ensure this doesn't happen for your application. Now, when it comes to foreground notifications, if you take Android 10, foreground notifications were actually there in the ongoing notification, which is in the top tray, it would come in. In 11, you can swipe them off. And if you look at it, your ongoing notifications, then you have a silent notification pane. And third, you have a foreground notifications pane. In 11, you have this foreground. So when you swipe out, it will automatically go to the foreground notifications pane, be minimized. You can always maximize it and see additional data like a full notification. But this allows you to declutter your notification tray a lot better. So this is just a visual change which has a user behavior. There is nothing that you as a developer will need to do. This is something that users will actually experience in their device. Package visibility, definitely something that a lot of people have to test for. This is primarily not a way in which for many versions of Android, for a longest of time, people have been figuring out if an app is there or not before calling the intent of that app. So if you're using, if you want to share something to WhatsApp, how do you figure out if WhatsApp is there on the device before calling the intent? You can call the intent and share data to WhatsApp, but how do you check whether it's available or there? If you go and do this query on Stack Overflow, say, how do I check for an application before launching the intent? The first thing will come is go use package manager and check for the package, if the package name is there in the package manager or not. That will be the classic answer that you will get. But now also that will be what you will get. Now, yes, that is a valid way of doing things. But earlier there were no restriction to what packages you can actually go and check if it is there. So some people would Just query all the package names and then figure out what the user has on the device. Do they have any competitor apps? Do they have any of their from the same developer? There are other apps, things like that. Now in Android 11, that is getting restricted. You have two ways of doing things here. The restriction is that either you will have to declare the explicit package name that you're going to query for using the queries element in your manifest, or declare the intent for which you are actually querying, which is you can actually say that you need com xyz abc application. I will query for this, which means the package manager will tell you will share a result with you if you query for that package name. If you query for any other package name with a direct package name query, it will return null, as if the package never existed on the device. But that is not an indication whether the package is there or not. It's just that since you don't have the permission, the system is not exposing any data to you. Now, there are use cases like creating your own share dialog. There, based on the type of data, you need to know what all applications you can launch. In that case, you have the option to actually specify the intent in the queries element. So it will let you query for all the applications with that given intent filter. And it'll give you a list of those applications, and you can actually check for and use that information to say build your share dialog and things like that. There are instances in which you want to query all the packages. There you have a new permission called as query all packages introduced in Android 11, and that is what you should be using if there is a legit reason why you need to ask for that permission. This basically is useful. This is basically useful when this is basically something that you want to use sparingly, because there will be policy implications also on this. You will hear about it during our next policy updates. Right now, I don't have the exact details for it, but yes, you do not use this unnecessarily. Query all packages is not a permission that is given for every kind of app. This is not information that is needed for every app. So unless you have a very legit reason that you can provide, you might not be able to actually get that permission. Now, tracking private data. One of the things that we have seen a lot of apps getting suspended for is unnecessary access of users' private data. Now, there are two problems to this. One is people have a incorrect understanding of what private data is. Third, and because of that, they don't know whether they are actually doing something wrong or not. In many cases, what I've seen with policy violations, when you explain to the developer, hey, this is the data you're unintentionally collecting and sharing, the developer is like, okay, I can change that. And they immediately make the change and upload the app back again. But a policy violation, one of the things I really want you guys to be careful about with policy violations is policy violation also has a history of violation. So when a new violation comes in and a potential action is taken by the policy team, they also look at the history of violations of that app. And that goes in as a signal to decide what sort of an action should be taken. That is why you would see that repeatedly when people violate policies, their accounts get terminated and things like that. And these things are extremely expensive operations. They have implications on your business. They have implications on the application. When an account is terminated, the only thing you can do is go ahead. All you can do is that if you have basically change the entire app package name and then re-upload it on a different account, that thereby losing all your user acquisition so far, and that becomes very negative for your business. So please ensure that policy violations are taken very seriously. You have to proactively avoid having violations, not reactively quickly fix this. How quickly you fix a policy violation is not the issue, not the thing that people are considering. It's how many policy violations you are making. So coming back to private data access, there is a new app ops manager collector class which you can use in order to figure out whether your app or an SDK is accessing some private data or not. Again, you can define different aspects or modules on your app as to kind of easily figure out where it is accessing and what it is accessing, and then identify and rectify this. So this is a feature that I will strongly advise most people to implement in their apps, because a lot of times, not majority, but I've seen far too many instances to my liking where the developer has never collected any private data, but one of the SDKs they introduced into the app actually was doing this, and their app got penalized for it. Now, when you actually package SDKs into your app and publish in Play Store, the developer policy applies not only to the code that you're writing, but it applies to all the code that you're actually adding in your package, in your application. So please be aware that even if you have not written the third-party SDK, you are liable to kind of have, you are liable to kind of ensure that there is no private data that is getting collected, and features like this will allow you to audit it all the time. So summarizing this, there are multiple changes that have come in for privacy, scope storage, one-time permission, background location, package visibility, foreground services, all these sort of things. This page, basically, where the reason I put in is because somebody can go back and refer to this later. I will not spend more time here. These are things that we've already discussed so far. With respect to new features, one of the things that I like most in Android 11, and I feel this is definitely going to make testing Android 11 a lot more easier compared to previous versions of Android. Testing an app on Android 11 more easier is app compatibility framework. Basically, what this allows you to do is it's a new tool which is only going to be there in a debug build, which means only going to be there in developer preview. This is not going to be there on user device builds, which means even in beta as well as in final release of the app, so rather the final release of the, not the app, sorry, the OS, you will not see this feature there. What this feature allows the developer to do is to turn off a certain restriction that the OS is bringing. Say, example, scope storage. Assume one of the problems that most of us who have tested on our app across multiple versions of Android have faced is there might be a new restriction that is crashing the app early in the user flow, which means maybe in the login screen or something. Without fixing that problem or without making a change to the code, you will not be able to test the rest of the app for other violations or other behavior changes. Now, with app compatibility framework, you will be able to toggle each of these changes and then test individually. Say you can toggle everything off and then just turn on scope storage and then test scope storage features and its impact throughout the application. So it will allow you to isolate and test one behavior at a time, or a combination of features together, a combination of changes together. Again, like I said, if your login screen itself is crashing because of a change, you can turn off that particular behavior and then continue on testing for the rest of the app to see where all the app actually is either crashing or behaving in an unexpected manner, and then identify all that and then go back and start fixing this. This will greatly enable testing to actually proceed faster. But like I said, this will not be there in a final release. So if a user device has Android 11 on it, they will not be able to change this behavior because the setting screens will not be even there on the final build of it. So this is only going to be there in developer preview. So please play with this and ensure that your testing happens, because I would advise that when there is a problem, right, you can actually go ahead and toggle things off and to kind of figure out and isolate what is causing the problem also, rather than go with assumptions. So this will help you build, identify the problem or identify the change that you need to make, or the change that is causing the difference in behavior, thereby creating a solution which is much better for your app. Refresh rates. Now, we know that there are multiple devices which have multiple refresh rates on the device. So what we usually see is higher refresh rates, sharper screen, things of that nature. But what you need to understand is supporting multiple refresh rates actually makes a lot of difference in how applications run on a device. Because some apps, for instance, games, for example, so when we say 60 hertz and 90 hertz is supported by the screen, it means a multiple of this is also, or you can also drop it down to 45 hertz and 30 hertz. The screen refresh can be done that way. Say, assume that your game has a very, very intense computation. If you're running at 60 hertz, you get 60 milliseconds to kind of run the computation. And if you don't do it in 16 milliseconds or in the background, you will start missing frames. Now, in order to avoid that, you can actually tell the device to now change to a lower refresh rate so that you get a larger window to do your calculation. So things like that can be done. So from an SDK as well as from NDK, you have the option to kind of suggest a refresh rate to the device and run it at that refresh rate to ensure that the users have a smooth experience on the screen. Because sometimes with certain calculations and certain operations, you cannot run the higher refresh rate or the maximum refresh rate and finish the computation within the time frame where the choreographer will not start skipping the frames. So you want to be doing this. Again, you can be also conscious about battery consumption with this. With a higher refresh rate, there's a slightly higher battery consumption, and you want to kind of, if you want to kind of control it with your application to a certain extent, yes, you can actually manipulate these things. So there is a very nice article of how refresh rates will affect applications. This is not just a gimmick given by OEMs to sell their device. This has implications of how battery gets consumed, how much time your app can actually get for computation between frame refreshes, things like that, which you as a developer can take advantage of. So please do read up on why that refresh rate matters, and then how you can, and decide how you can manipulate this to your advantage. Going to the next one. Yeah, resume on reboot. Okay, one of the things that you guys might have seen is when you actually run an OTA installation, you have to log into the application for the OS to run, OS to kind of boot completely. Now with Android 11, the whole idea is to make OTAs come over the night, where the device is actually connected to power, and then there's Wi-Fi, which is the most favorable condition for doing an on-the-air update. You want to be able to do the update, restart the device without without any user interaction, and apps will be able to function normally after OTA reboot, rather than going to a restricted mode. If you take a, say, Android 9 device and set it to do an OTA update, you will see that unless you log in, all your applications cannot run normally, because it has to complete the boot process after the user has logged into the device, basically by providing his or her PIN. This is a limitation that we are removing in using the feature called resume on reboot. In Android 11, the OTA updates are going to be much more smoother. They can happen with and complete, and then apps can run functional, can run normally without, run normally after the OTA boot. So this will this is something that is a user-facing thing. You really don't have to make any changes in your application to take advantage of this. But this is something that makes the OS perform better towards a user's use case. There is 5G state API. This has new APIs called as bandwidth estimator. There's a 5G dynamic meteredness API. There are multiple things that have come in. For if you are making an app which is only shipped in a region like India, then where 5G hardware is there, but there's no 5G network available, you really can't take advantage of these APIs. So if you have a global app where, say, you have a lot of users in the US, there they have 5G networks available. Then, or your user apps are used in Japan where there's 5G network available. You want to kind of take advantage of this and ensure that you improve the user's experience, taking advantage of these two APIs. This is also a very niche use case where there is call screening improvements. So if you have a dialer app sort of a thing, there are improvements in call screening. The apps can report rejection reasons and things like that to the system. So this is very niche. If you're not really doing a dialer app, you might not really want to kind of look at this change. Wireless ADB, I really like this one. This has made my desktop a lot more cleaner. And this basically, I have seen this come before as a plugin or something by a third party, but that for me personally, when I tried working with that, it did not give me a lot of success. But with this baked into the OS, the wireless ADB function allows you to like communicate, do ADB operations, install an application, debug it, all these things without having a device connected via wire. It can, if your computer as well as your debuggable device is on the same network, your ADB will actually list it as one of the devices you can interact with. So you can actually push information, get uh, uh, get all the logcat and things like that, without actually having the wire. Say a lot of times you really have to pull out your wire, connect it. You might be at a like airport is one place where I've done this stuff million times, where I have an hour to kill. So I would take out my laptop, then connect my phone with the cable, and then there's no place to keep the phone. And I use a short cable for really short one. Something like this is what I use, which is like really short for debugging. And then it becomes really tricky. So I have to keep my phone on the on the screen. This is, and this that makes it a lot tricky. So every time the phone comes, my screen starts flickering, and yeah, it creates more trouble than I really wanted to. But with the wireless ADB, I can kind of keep my phone anywhere within the vicinity and start working with it. It would work. I have not tested this on a corporate sort of a network where there are multiple devices, but on my home network, this works beautifully. Beautifully, and this one was something that you can use straight off. And there are some changes in terms of the network security part of it with respect to this in 11. And screen recording, when it comes, there is a few changes that have been done, because we've basically, this is usability changes in if I would consider it, when you're actually screen recording an application, screen recording, the screen recording, one of the two most common use cases, recording audio or showing touches on the screen. Earlier, user would have to now go to the settings to do this and come back. Now this is going to be there on the notification panel itself. So you can always toggle the record audio or show touches on the screen. Because most times when users want to record how an application is performing, like a tester is going to send the developer how the crash is happening, they would actually record the screen and then realize that, oh, they're not showing the touches. So then they go to settings, have to toggle this, come back, and then run the flow. That sort of setting can be very easily eliminated. Again, if the screen is being recorded from a user's perspective, the notification actually is red in color, which gives the visibility that something is recording, and users don't skip that skip the fact that the recording is continuing. So that also gives the user a lot of cue that there is there. There were 3 buttons in notification, which was already removed, and now these toggles are there, which is a much better UI to work with. Notification history is another thing that we have added. The UI that you're seeing here is not the final one. There might be changes to this. You might already be seeing changes. I've picked it up from a developer preview one. But the whole idea is that if you dismiss a notification, which I have done many times, I go and clear my notifications, I clear all. Then I realized there were few notifications which had coupon codes for something, which I can't see later, and I miss out on that. So things like that all happen. So in 11, you can actually turn on notification history, and then from the notification shade, you can go into the history and see what you have dismissed, what all notifications you received on the device. Like I said, there are changes that might happen to this. You have to turn it, if you want to try it out and you're running Android 11, you've got to go and turn it on in your from notification history in your settings. Then only this is not auto turned on. But this is quite a useful user feature. One of the other things which is more serious from a technical perspective is the use of non-approved SDK APIs. So if you take Android, for instance, there's a set of APIs that are available. Many of them are private APIs. SDKs and apps have, some of the apps have, we've seen that many of them have been misusing the private APIs to kind of get certain behavior. Now, because of that, a few versions of Android before, we actually have this classification of whitelist, graylist, and blacklist. And light gray and dark gray, I leave it, but you can also be a graylist and white, black, and gray. So basically, whitelist is like an allow list, blacklist is a disallow list, and graylist is something that we allow temporarily. That is what you should think about it. Anything that is in the allowed list with something that you can go and use in your application and not be worried about if the behavior will change or this will be deprecated later. Because if there is any change to it, we will communicate it to you. upfront. But anything that is in the disallowed list, which are private APIs, you will see that those things can change at any point of time. OEMs do not have to have the same behavior for those. So you might see on Pixel a certain behavior for an app, but you might see a completely different behavior, or that API not even being there on a different OEM device. So anything in the disallow list, do not use them. Gray list is something like a temporary allow list, which means in the next version, this is something that you shouldn't be using, but for the time being, if you use, we will keep warning you in your log cat, but we will continue to, we will not say, stop you from getting that operation completed. Say it is something like you're picking a sensor data using a particular API. If it is in whitelist, you will get that sensor data. If it is in disallow list or the blacklist, you will not get that data. It will always return null. And if it is in the gray list, you will get it for the time being, but there's no guarantee in the next version you will get it. So what you got to think about is that those are APIs that you need to change or avoid using. If you have getting and if you go to strict mode, and if you run strict mode, you will actually be able to identify all the disallowed APIs that you're using. Gray as well as blacklist, you will see what all you need to change. The other place you can go and check is if you upload your app to Play Store, you will the pre-launch report now actually will show you the list of APIs that you need to change, either stop using or find an alternative one which is in the public SDK APIs. So please ensure that this is something that you take care, because every version of the OS, what we're doing is we are moving more things from gray list into the blacklist. So more things which are temporary allowed are disallowed in that version. Because without a single code change, your app will run. Your app will run without without any code change. Your app will stop working when they're running on a different OS version, and that is a behavior that you don't want to have. So ensure that these things are taken care of now itself. The process termination status. There's a ring buffer within the app where, within the OS, where the app can go ahead and request information of why it exited last time. This is particularly useful when, so what happens when an app exits on the device, it actually writes some information into this app exit info ring buffer. So the next time the app launches or you relaunch the app to find out an error, you can actually go and fetch that data from the buffer and then use that information to debug. This is particularly useful when you want to kind of understand why a certain crash happened on the device. Sometimes your crash reporting tools do not share ANR, why ANRs are happening and things are, or why a crash really happened. This one will give you additional data around it, and this is something definitely should be there in your builds for, but this will work only on Android device. So going further, have this so that your apps, you have more understanding of what is happening. Now, phone permissions again, there is fine-grained phone permissions. Now, if you look at phone permissions, they are considered to be dangerous permissions. Now, reading phone state is different from reading phone numbers. In previous version, all this was considered into one group. So if you just wanted to read phone numbers or you just wanted to read phone state, you would still have to, the permission was read phone state and you will get all these things together. Now they're separated into two different permission buckets, and read phone numbers is something that is more like a privileged one. Only certain apps will which actually has the requirement for that information will get it. So you want to revisit your use cases where you are using this particular function calls and getting data for maybe a different part of your algorithm. So you want to kind of ensure this does not get this permission. Is either you add this permission or you revisit the reason why you need this information in the first place. And lastly, there is Conversations API, where you can actually pin a particular user as more important. Say you could, in my case, my family members, I put them as important, which means that if I get a message from my wife or my mom, even if my phone is in a no disturb mode, it will actually show up that information. The bubble will be there by default. So having a user giving not an app the priority, but particular identities within an app is something that is allowed. So people and conversations are becoming more important. They will be bubbled up higher than other notifications from the same app. So this makes it much more easy to figure out important messages and important information and certain conversations. Say we have hundreds of WhatsApp groups. If most people have like tens of WhatsApp groups in their thing. If you give WhatsApp an active permission, which is like something that can ring, every one of them will keep disturbing. You can actually take particular people and make them important, and rest of them all can be silent. If you go into a don't disturb mode and your boss sends you a message, you're not going to miss it the next time. Boss/wife sends you a message, you're not going to miss the next time. I mean, yeah, bad joke if some of you might not relate to it, but yeah, anyway. But that's a kind of very useful feature for most people. I've been using this and I see that I don't get disturbed as much because I can make all the others, the less important conversations like the group chats you are in, to go completely silent. So the app is silent, only certain conversations within that app becomes more important, and they get surfaced up better for you. And wrapping up, this is not a comprehensive list by any order. There are multiple things which are there, like the media state one, the batteries optimization part, screenshots, gesture settings. You can now have different sensitivity for like different actions for left swipe, right swipe, and things like that. And this whole there are a lot more features. So I've only called out things which we see as quite useful for a lot of people and might impact people. But based on your use cases, please do read the documentation and understand what all features are there and what all features might affect you. Like I said, I haven't covered everything. With the interest of time, this is the max that I could cover within the time given to me. I'm still over by 4-5 minutes, but I hope this was a useful session for you guys to give you an idea of the most impactful features for most developers out there. Generally, most of these apps, most of the apps will be impacted by a combination of these APIs. But again, like I said, there are more features, there are more UI changes that are part of the OS that you will have to understand. So please do read the documentation and find the gaps and update your apps accordingly. Lastly, reiterating, we are still in the beta phase right now, which means there's a lot of stability that is getting added to the OS. It's a good time to start making changes to your app and iteratively start releasing it to the real world and seeing how people are reacting to it. See if there are any bugs that are coming in your algorithms or if there are any bugs in the implementation that you're seeing. And by the time the final release is out there, your apps are working as good as they are working on any other version of the platform. That's it from me. Thank you for patient listening, and that is my Twitter handle. So if there are more questions, feel free to ask me on that on my Twitter handle, Sanjeev. I usually post stuff about Android most of the time. The lockdown has made me post a few personal things out there, but then still, that's just cabin fever, in my opinion. But please feel free to ask me questions. That's the fastest way to reach me. So if you write something there, most probably you'll get a response very soon. Thanks for the patient listening, and stay safe, everyone.
Thanks so much, Amrit.
Thank you. Thanks for the opportunity.
Yeah, you have a nice day.
Cool. Are we taking questions, or is it more like you want to take questions offline? I forgot to ask you about this earlier.
No, if anyone has any immediate questions, you can probably unmute yourself, ask.
Yeah. Otherwise,
we can...
everything to be answered. I'll try and share as much of information that I know. But if there is anything that I couldn't, please post it on the Twitter channel again, and I will find an answer and respond back to you offline.
Sure, that works so much. Thank you so much. Thanks for finally speaking at Mad.
Yeah, it's never worked out because every time fires, so somebody asks me, I'm either not in town or that week I have another event to deal with. Yeah, the lockdown has given us a lot more opportunity to kind of speak at events. I think because
Yeah.
the whole the amount of travel has reduced. For me, it is in 9 years. This is the longest I've stayed at home. Uh, that is, it is a good thing. In that sense, that's the only good thing about this lockdown for me, at least.
At least some of us are having it good.
Yeah.
I'm just trying to see the bright side. That's all. This isn't good. I don't like it one bit, but I'm just desperately trying to see the bright side of things.
Yeah, I think it's important for all of us to do that.
Cool. If there are questions, please. If there aren't anything that you want to ask right now, please put it on the chat, Twitter, and I will try and find answers for you. Okay.
Yeah, we have about 3 or 4 minutes before Saurabh session. So
So if other questions coming on the chat,
someone asked about media controller.
so what is some information about the media controller? So yeah, with the media controller now, one of the changes that you will see is that you will actually have on the notification tray media controls. It's not like you are having a notification with media control. You have it a part of your settings, like a quick settings tray sort of a section. You might have seen a picture of it. Let me see if I can go back to it. See, if you see the first picture, right, you will see your current playing controls of a player right there. So you just have to enable that feature and it will actually come in there. It is like a carousel where the last 3 ones are there. So it's swipeable and the last 3 ones, and it's there for a certain amount of time. I believe it's this is there as long as a session is active. But that was not finalized the last time I actually requested for additional information. That data wasn't finalized yet. I'll have to see what is the behavior on beta 3 and then maybe reply back to you on that one.
So in beta 2, what they have did that media controller right now is in the notification panel. So let's just say if you open YouTube Music, as you can see in the screenshot, it is currently in the notification section, but now it's separate. And now it's
that's why I say these things actually change between developer preview and beta because we get a lot of feedback from developers on what is working, why some things will not work. See, like any other team, we take a set of user research and go ahead with that data. But when we put features out there in the real world, during developer preview, we get a lot of input from external developers, which sometimes make us change things back. So sometimes we revert changes, or we might bring changes, introduce changes into the introduce changes from what we have released out there. So those things, like I said in VP, it was not finalized. Last time I checked for more details about it was during developer preview, and this was the behavior then. I really have to double check on this on what is the final thing yet. Because even with beta, some things can change as long as it's not developer facing. Things like this, which is more of a system UI sort of a thing, things can change even during the beta phase. It's unlikely, but things sometimes do change depending on how much feedback we get and how valid that feedback is. So let me try and answer it by taking a double check again. I will move to the next question. As per the new privacy policy regarding background location, what kind of app use cases, what app use case will be allowed to use access background location? It is not very different from, as long as you're declaring the background location and it's in a if you're actually getting that in the background, like using a foreground service to kind of get it, it remains very similar. I can share the documentation for it for you to kind of take a look at that completely. I'm not sure I understand the question completely, but I'll share the documentation on the chat. Are your Twitter DMs open? I think it is. I don't remember changing that. Yeah, if there's anything particular, please feel free to write. I believe it is open.
hey, as you mentioned, there in scope storage, there we use for complete access to the storage. We use for the apps like File Manager and all those. We
Mhm.
need a, Google Play policy, something like this.
Okay, yeah.
So for
There
our
is a permission. There's a new permission added
hmm.
for you to get
so
access. We need a
so for means like for the debug build, we have to access this Play Store policy, and suppose we don't want to launch the app on the Play Store, and we just want to use it as an open source project, then we have to use this play policy in that thing.
If it is an open source project, so we are actually controlling it as a distribution mechanism. The OS is capable of granting you this. I mean, like the user is capable of granting you this permission, but we are, from a distribution perspective, we are actually controlling it. So it's a policy that controls the usage of permission. From a pure technical perspective, there is a new permission that is added to the OS. It works like any other permission. But when you distribute it through Google Play, a policy will be applied in such a way that only apps which have a legit use case will be allowed to be distributed in Play, which access this permission. So if it's an open source project and your distribution is not through Play, you shouldn't have a problem. Technically, it will work like any other permission. It'll ask the user to give the permission. If the user gives it, it will continue.
Okay, thank you.
We're running out of time, so
Cool.
future questions, please take them offline. Amrit's Twitter handle is on the screen. Thank you so much again, Amrit.
Well, it's my pleasure. Thanks,
Hope
everyone.
to see you in Bombay sometime soon.
Hopefully.
I hope.
I'm trying to see the sky outside my house. That's the first thing. Cool, guys. Have a good time.
Yep. See ya.
Now.
Right. Thanks, Amrit.
Bye-bye.
Thank you.
Okay, so we are gonna start our next session today. So I'm very excited about all of the changes that are happening in Android 11, privacy to be particular. And to talk more about that, we have Saurabh Arora with us. He's a Google developer expert for Android, and he's based in Singapore. He works at Wiki, where he leads the Android engineering team. Apart from Android, Saurabh is a fitness fan. So if you're having difficulty maintaining that shape in this lockdown, he's the guy to go to. Today, he'll talk about changes in Android 11. So let's get started, Saurabh. All over to you.
Hey, hi everyone. Thanks for tuning in on like a Saturday. It's a late Saturday afternoon. Okay, today I'll be talking mostly about what's new in privacy changes in Android. The last talk did cover a bunch of privacy stuff, but we'll try to dive deep into what these changes are, how you could go about preparing your apps for these changes, and what the future of Android would be when it comes to privacy. All right, so over the last couple of Android releases, there's been quite a lot of focus on privacy. Okay, and these changes are important to protect users' data and let them know what is happening with their data, basically. So as you saw in Android 10 and even in Android 9, there was a lot of changes introduced, like foreground services were introduced, location permissions.
Saurabh, your PPT screen is not visible.
Oh, wait, let me try that again. And no webcam as well?
We can
No.
see you on the webcam.
Yeah.
Okay. It says me screen sharing is on. Let me turn it off and on again. Do you see it now?
Yeah, we can see it.
Oh, the same thing. Wait, let me just go back here. Okay, sorry about that, guys. Okay, yeah, so I was talking about, privacy changes in Android. So yeah, in Android 10, there were a lot more of focus on locking down the platform and making it more secure, basically giving back access to users to their personal data. And as you use smartphones these days, there's a lot of private and sensitive information on the phones about you. And smartphones contain a lot of information about our lives. So it's really important that as a user, the user has trust in the ecosystem, in the platform, and in the app that they're using, that nobody is actually abusing the data access that they're getting. So with every release, Android is making a lot more of effort to make it more of a privacy-centered platform. So in Android 11 takes this privacy-focused changes to the next level. What we have is we have changes in permissions. We have new foreground services types. We also have scoped storage, which is no longer optional, unlike the case was in Android 10. You have a few changes on package visibility and a really cool new feature about data access auditing. So first, let's look at what permission changes have been introduced. So in Android 10, when users were given the option to select, let's say, the location permission, when there was an option to say, oh, only allow the access while the app is in use, what turns out to be the case is users are very, very highly likely to choose this scenario. In fact, like about half of the time, the users actually chose the scenario where it's just granting you access while the app is being used in the foreground. So based on this feedback, I would assume the team went ahead and provided users with more granular control over their private data, especially the microphone and the camera permissions. So along with the option where you have that, oh, grant this permission only while I'm using the app, the users will now see a new option in the dialog, which will say, grant this one-time temporary permission for this app. And as Amrit mentioned in the talk, this one-time permission is actually only till the app is in the foreground, and for a few seconds or a minute when you leave the app and the app goes to the background. But after that, this permission is just revoked for the user simply because this was just a one-time permission. And this now is not just for location, it also extends to the microphone. So let's say there's a transport app, and it offers a VoIP feature to actually set up a communication channel between your driver and the rider. So for such kind of an app, it needs to make voice calls. So the user can choose to just allow permission just one time. Let's say like now the user has decided to communicate with this driver over a call instead of using the regular text messaging mechanism that the rider might be used to using. So in this scenario, the rider could be like, oh, I want to call this one time, and that's it. I don't foresee myself calling every other driver. So I don't want to give you permanent access to this, my microphone. I just want to do it one time. So this is where this one-time feature comes into play. Similarly for camera access, like let's say your VoIP feature also allows video calls. It's the same process. The user could say allow one time. And here I would like to also point that this allow one time option is actually only for location, camera, and microphone. Other dangerous permissions for which you need to prompt the user for permission grant, they still continue to have the two standard options of allow and deny. There is no concept of allow one time or only allow in the foreground. All right. So as developers, we are wondering, okay, now there's this new option in the prompt, which is allow one time. So how does this really affect us? Like, what do developers actually really need to do to adapt to these new changes? Actually, nothing. Like if your apps are currently following the best practices, then you actually really don't need to do anything to get it up and running, because even in the previous world, without one-time permissions, the users could actually go to system settings and be like, hey, revoke the permission for this app. So app developers always had to be prepared and live with this reality that the permissions could be given to them and they could be revoked anytime the user feels like it. So what are these best practices? Like, I'll go through a quick run through about what these best practices look like. So basically, whenever you need to access anything which is a dangerous permission, you should check that permission is granted to you or not. And it's important to check if that permission is granted and not keep a cache of that permission, because the user could go ahead and deny that. So these permissions can always get out of sync if you're caching them. So every time you have to use a certain feature or access certain private data which is gated behind a permission, you should always check for it. If the permission is granted, go ahead and perform the operation that you're looking to perform. But if that permission is denied, then the system would send you a call back letting you know that either the user doesn't have this permission, or either your app doesn't have this permission, or B, you need to show a request rationale to the user where you actually give them more information about the context of why you need this permission. So you go ahead, request for this permission, and if the user denies it, just make sure to fall back gracefully, explain to the user that this current functionality isn't supported because the user currently just chose not to give you this permission. So if you have this flow in place, one-time permission is seamless. It just works exactly the same way. The first time the user opens the app, you grant them the permission. The user grants you the permission. Then the user opens the app second time, because you're checking for the permission again, and you're not assuming that just because you were given the permission last time, the permission is still available. If you take out that assumption away, one-time permissions would just work seamlessly for you. And given the fact that these best practices existed earlier and apps were expected to follow this, if you're following this, one-time permissions work. And given that assumption, your one-time permission, the prompt for the user as an option to select one-time permission, that will appear in any app that's running on Android 11. Even if you haven't really updated your target SDK level to say, yes, I target Android 11, irrespective of that fact, one-time permission as an option will be presented to the user starting with Android 11. So even if you're not yet ready to support Android 11, I would say let's try to strive to adopt best practices so that such kind of changes require minimal developer effort on our side. All right. Okay, so that was about one-time permissions. And now let's look at location permission in general. Like, location permission is very special in the sense, like, previously, even in Android 10, location permission was split into two types of access. There was a foreground access, and then there was a background access. And Android 11 actually now encourages app to really adopt this practice. And what I mean with this is, now Android 11 establishes this incremental request permission for the user, that first you're supposed to request foreground access, and once you've been granted foreground access to the app, you can go ahead and request for background access. So let's see what this looks like. For foreground access, nothing really changes. You continue to request for the user. The user will get their standard prompt, which is allow while using the app, allow one time, which is a new thing, or just deny. Now, let's say the user gives you allow while using the app permission. And now you're an app which needs background location access. Let's say you're a geofencing app or an app which really needs to know that the user is leaving this location. So you're a smart control, one of the smart home apps. So you really need to trigger some actions for the user based on their location movements. So you really need background permission. So once you've granted foreground access, you can go ahead and request for background location. And in background location, once you ask for background location, the user will no longer get an in-app prompt. The in-app prompt has been taken away, and what users get is that they get a system dialog which asks the user that, hey, do you want to actually navigate to do you really want to grant this app a permission, the background location permission? And if the user says so, the user is actually taken to the system settings, where the user now has the option to actually grant you a permission for allow all the time. And do note that at this point, the user can still choose to deny that permission to you. So it could be a scenario where the user granted you foreground access, then you prompted for background location, which took this user to the system settings screen. And over there, the deny option still exists, and the user could choose deny. And then when you come back to your app, you would have lost even foreground access. So again, the best privacy practice, the best permission practice still tells you that anytime you want to access any dangerous permission related user data, always check that if that permission is actually granted to you or not. All right. And since this background location flow where you're taken to the system settings is something that would occur only if you update your target SDK level, There is a backwards compatibility option built in right into Android 11, where if there's an app which targets Android 10 and below, they're still allowed to request for foreground and background permission in one go, even if you're not following the incremental process. In that scenario, the system will still not present users the option to do allow all time right inside the app. Instead, there'll be a slightly different dialog, and that dialog will actually have an option for the user to go ahead and go to the system settings the same way like it is for apps that target Android 11, that they can go to the system settings, grant this permission, and your app will then be allowed to operate in the background. All right. Okay. Next up, given that we've covered, let's stay on permissions. There's also auto reset permissions. So look at auto reset permissions as being very similar to user going to system settings, going to your app, and then revoking certain permissions for you. This works exactly the same way. Let's just say it's now automatic. And what this does is, if a user has an app installed and then the user really forgot about it and the app was granted one of the dangerous permissions, the system would see, hey, the app has not been used for several months, and the system will auto reset those permissions for you. Now, one of the bigger questions that even I personally had when I looked at this was, what does it really mean by when you say the app has not been used by the user? Like, let's say, what if it's a background app? What if I'm accessing location permissions from a foreground service? Like, does that count as user interaction? Unfortunately, no. Foreground interaction only and only applies user actually opening your app and using it. Even if you sent out notifications to the user and user interacts with those notifications, this is not counted. Unless, of course, the interaction with the notification actually resulted in the app opening. Then it's a foreground access of your app. But if the interaction with notification was something which did not actually open your app, let's say it was a button and which triggered some service in your app and you perform some action for the user, that does not count as foreground interaction with the app. So in that scenario, the system would count your app as not being used, and the counter or the timer for when the auto reset permission kicks in will continue to take place. Again, important to highlight here that this feature also only kicks into place if you update your target API level to Android 11 or R. If the users are running apps which are not yet ready to target Android 11, but they're running it on Android 11 devices, the system will not auto reset permissions for them currently. All right. And whenever the system decides to auto reset a permission for the user, the system will present the user this a dialog to let them know that, hey, we have revoked certain permissions for this app for you, and the user can go in and choose to re-grant the permission if the user feels necessary, or maybe go ahead and uninstall the app because the user realizes, hey, I've not used this app for 2 or 3 months and I don't really need it anymore. But here you might be wondering, hey, what if I have an app which primarily just works in the background? It's a smart device connectivity app, so it senses your movements and patterns and just works in the background to switch on and off your gadgets for you. Or it's something which is constantly syncing users' data to the cloud or providing family safety features. Like, what about me? Like, I am not an app which primarily focuses on the foreground. In this scenario, Android still offers you a way to actually inform the user that they can go to the system settings and actually disable the auto reset permissions for your app. So you can invoke an intent with the settings action application details settings. So this will take the user to the system settings page of your app, where they will be presented with a auto reset prompt, just like I had shown earlier. Like, this prompt would come up, and the user can choose to toggle this off if you've educated the user and the user is aware that, hey, this app is just working in the background. I should not really reset the permissions for them. For this, I should tell the system to not reset permissions for this app. So this is still possible if you're an app which works primarily in the background. But for most common scenarios and for most apps, this should not necessarily be needed. And as long as permissions best practices are followed, this is another feature which should not require any developer effort as long as you are an app which does not work in the background. All right. So now that we've talked about permissions, let's look at a bunch of new foreground service types and values that were added in Android 11. In Android 10 actually had introduced firstly the concept of foreground service types. And what in Android 10, the idea was that apps can declare their intentions to access this foreground service. Like it was just saying that it was not compulsory for you to say that, hey, this is the type of data that I'll be accessing in the foreground using a foreground service. It was just encouraged for the apps to do so, to be good citizens and inform users through the notification that this is the kind of this is the kind of private data that I'm accessing by running as a foreground service. But in Android 10, two things were still compulsory. Like your foreground service will not get that data if you did not declare it that you'll be accessing that data. This was about media projection apps such as Android Auto, Bluetooth TV, or other device or other services that were monitoring connections, and definitely location. So if you had a foreground service which did not declare its foreground service type as location, the service will not get access to location. So now in Android 10, we have a couple of more which are enforced. First up, we have the camera. Now this will be enforced. So if you have a foreground service which tries to access anything related to the camera and it's not declaring its intention to do so, it will be denied access to the camera. This does not just needs to be the camera preview. Like if you're setting up the camera, if you're doing a warm start to make sure that when the user actually needs to use the camera, you're ready to provide an instant access to it, your service still needs to say that, hey, I'm a foreground service type camera and I'll be accessing camera location, camera details, else the system will not allow you to access. And similarly, as we were used to doing for location, you could just go ahead and say, this is my service, this is the foreground service type, and say camera. And along with camera, microphone also is a new foreground service type and is the same concept as location and camera that we just discussed. That if you're saying that I want to access microphone, if you try to access microphone information without declaring it, you would not get any information. And now foreground services allow you to define multiple types in the same field. So you can have one service which accesses multiple type of information, just that you need to be upfront and declare it to the user. All right. Yeah, so just a quick simple recap. Mostly for permissions and for foreground service types, the biggest changes that will affect developers and users would be camera and microphone, along with location, which was already enforced and being clamped down in Android 10. Okay, so that was about permissions and how we access user data. Now let's see package visibility. So what package visibility really means is, like, previously before Android 11, what users could do is what developers could do essentially is we could check what are the packages that are installed in the app. You could query a list of all the packages, like you had sometimes some apps were using that kind of information to build custom share sheets to show to the user what apps are installed and where they can share the content. So this was the use cases where you would access all kind of packages installed. Now Android 11 tries to rein that in so that every developer is a good citizen. We should let users know that, hey, we'll be checking what apps do you have currently installed. And this is what users would earlier do. So as a developer, you would do package manager and you would be like, hey, tell me a list of installed apps. And earlier this would return you the list of all installed apps on the device. And you would use that to, as I said, create share sheets or any other kind of information that you would want to present to the user. So you were actually looking to query the package manager and then interact with these kind of information which you would get. And share sheet is not just the only example. There are a bunch of other use case scenarios in which developers would want to access what packages are installed. And even though we are saying package visibility is now restricted, a lot of common flows don't really change. So if you're using some of these common flows which which I'll try to go through now, you shouldn't really worry about that this will impact your app. So what common cases are we talking about? Like, let's say if you wanted to get information about your own app, right? This doesn't change. You can still get it. If you're trying to get access to a list of all packages, it's not this API is gone for you. It's just now it's returning less content for you. So a call to package manager get install packages would now no longer return you all apps, but it will still return you your current calling app. It will return you system packages that are installed by default, packages that implement core Android functionality, such as the gallery, messaging. These kind of apps will still continue to be returned to you. And if you're using, similarly, if you're using package manager to, or the view intent to actually just send an implicit event intent to the system to capture, let's say, an image and open the camera, this still continues to work. So if you're not querying for, hey, is this certain brand of camera installed, but instead you're choosing to just, hey, fire off an implicit intent with image capture and say, just capture an image for me and let me know when that's done, this will work as expected. These kind of behaviors are not changing. Also, if you have content providers in your app and you expect other apps to query your content provider and get results back, this continue to work as well, because this is a content provider level interaction rather than a based on the package type. So this will continue to work. But so what really changes? So what changes is scenarios which are very more specific. Like if you're trying to query, hey, is this certain app installed? Like let's say in this example, another app, is it installed in the system? The system is going to tell you name not found exception, even though this app might be installed for the user. So you no longer have access to what specific apps are being installed. But I think the Android team still understands that there might still be scenarios where, there's certain scenarios where developers really need to know that is a certain app installed. So instead of giving you access to all apps, there's a new queries there's a new queries element introduced in the manifest file, and you can add that in where you can detail a list of packages that you want access to. So let's say you're an app and you want access to certain specific packages because maybe you're working in an organization and you have multiple apps that you build, and from one app to the other, you need to direct the user to another app, or you need to take them to the Play Store if that app is not installed. You can actually do that by specifying a list of apps, the list of packages that you want access to. And these only and only these packages access will be granted to you. And when you do package manager and you do the get installed packages, these apps along with your own app and system packages, this information will be returned to you. And it's not just specific packages. You can also query and interact based on intent filters. So let's say you're building a share sheet and you want access to not all apps, but only apps which allow you to share an image. So you can specify in your intent filter that, hey, I want access to all these information about if any app is installed that works with this intent type. So you can go ahead and set that up in your queries element as well. Right? And in case you need to interact with all apps, like there's some reason or there's some use cases that you have that you need to access all kind of package information, there's a new permission which has been introduced in Android 11. It's called query all packages. You can put that in, but as Amrit mentioned, if you are looking to release such kind of an app on the Play Store which has to access all packages, there'll be a play policy shared in the future. I think it should be shared very soon with guidelines and how you can go about, like what will be the regulation and policies behind allowing such apps to be distributed in the store. So it's still possible as long as the apps continue to adhere to play policy guidelines. And so I'm not absolutely sure on this, but during my debug testing and when I played around with Android 11 and I tried to give this permission, like tried a sample app which has this permission, the debug builds continue to work absolutely fine. I get this permission immediately. So I think given that this is saying that look forward to a play policy, this is probably only if you're looking to distribute production versions of your app through the Google Play Store. All right. Okay, so along with package changes, there's a few neat little, let's say a few delightful user experience changes with regard to package manager as well. So I like to highlight them as well. These are some common flows that as app developers we have in our apps, and some few new changes in Android 11 can make them better. So if you use the current scenario where right now you ask the user to, you have a link and you create and you send off an intent to open this URL for you, users are generally presented with this disambiguation dialog, which is, hey, do you want to select the web browser or do you want to select this native app which is able to handle this uh, deep link correctly? And in this scenario as well, what a lot of developers, what we tend to do is we try to use the package manager here. Like instead of just firing it off, you would check the package manager that, hey, is there any app which can handle this deep link, which is not a browser, right? So you would go through the package manager, see what all apps are returned, check, is there anything which is not a browser, and just trigger that off. So to make that kind of process easier and not have you use the package manager, there's a new flag called flag activity require non-browser. So what this does in Android 11, the system will go ahead and do this package manager check for you that, hey, is there some app which can natively handle this link, and this app is not a browser? And if that's the case, it will just go ahead and launch that app and not present the disambiguation dialog to the user, eliminating the complete need for us developers to query the package manager and make that decision ourselves. And because now you're saying require no browser, this will continue to throw an exception in case there is actually no app. So in your exception handler, you can cache that and then go ahead and decide to use your in-app browser or a Chrome custom tab, or just let the system browser handle it for you, depending on your app requirements and your own business UX flow. Here, I would also point that there's another, since this is a link, there can be more than one app which claims to open this link. Like let's say let's say you have a XML feed, right? And you've got more than one app on your phone which can react to XML feed contents. Like there's one kind of RSS reader that you have in your app, in your device. What you could do is you could also, and you really want to avoid the disambiguation dialog for the user, there's a new flag called flag activity required default. Now what this does is this will check in the system that is there something which is set up as the default activity for this URL. Like the system has said, use this one always. If that's the case, the system will again skip the disambiguation dialog, directly jump to that default app. And similarly, because you've said require default, if there's no default setup, you will get an activity not found exception. And in your exception handler, you can choose to follow whichever strategy you feel like. Like you could next default to flag activity require non-browser to then present the disambiguation dialog to the user and allow them to select anything that's not a browser. So this kind of scenarios hopefully should eliminate most of the package manager use cases that we have inside our apps and make it easier to adopt these new Android 11 changes. All right, okay. Next up, one of my favorite things in Android 11, that is data access auditing. Or let's say, why did my app actually use this data? Like I didn't intend this to happen. So this new feature actually allows apps to discover potentially unwanted or unintended access to private data. And the best practice for privacy is always be transparent. Users should know why their data is being accessed. And not just users, developers should also know, why is my app accessing this feature, this private data? Maybe I have a video call app and then I'm accessing camera. That's clear. But what if you have a video call app which does not have any storage related information, but it does end up accessing user storage? Like developers should also know why these kind of behaviors happen in your app. So, and these kind of scenarios are very common for large apps that have orphaned code. Teams move on, people wrote the code and now they're no longer working for the same company, and you don't really know why or where this kind of private data is being accessed. Or sometimes we have, third-party SDKs, which piggyback on the permission that was granted to your app and actually go ahead and access these private data, which without app developers even knowing that this is happening, that some kind of private data for the user is being accessed by some third-party libraries. And these kind of information sometimes slip through from developers, and even users don't know. So this new data access auditing allows you to capture that. So imagine, okay, wait. Yeah, so imagine like your section on the left that I have here. These are like bunch of code lines, right? And these certain pieces of code actually go ahead and access certain kinds of information. So what this data access auditing would do is, the moment you access this certain kind of permission, certain kind of data, before this data is actually returned back to the caller, the system will go ahead and log the entire stack trace of when this data was accessed. And this is done before the permission is returned, before the data is returned to you. So the system has an exact stack trace of where and when was this data accessed. I think if you look at the API, then it will probably be a lot more clearer. So what we can do is we can first set up an app ops manager. And once you get an app ops manager, you can set up a noted callback. And what this callback would be, that this callback would be triggered whenever there's a synchronous or an asynchronous access of data. So what do I mean by synchronous, asynchronous? Certain data you just access. So you just query that and you just get it back immediately. That's synchronous data access. But certain data access is actually asynchronous, like sensor permission, sensor information, that is asynchronous. It's a callback that comes back to you. So this ad ops manager callback will be triggered whenever there's a synchronous access and an asynchronous access. For asynchronous access, it's triggered when you set up a callback. So again, you would know the stack trace exactly that at this point a callback was set up to access this particular data for the user. And if you want to do this for your entire application, you can set this up inside your application on create. But let's say if you want to localize this to certain activity or certain fragment of your app, you can go ahead and do that inside your activity on create or your fragment on create respectively. All right. Okay. And so here, what we discussed right now is you can get access to stack traces, right? But not always is getting the full stack trace actually helpful. Like certain developers might want to attribute such kind of access to certain features in the app. Like let's say you have a bunch of features in your app. Like let's say you have a find friends feature and you want to say that, hey, I want to attribute that this data, that when the data access auditing feature told me that this private data was accessed by this piece of code, I want to attribute that to a feature so that I can have a holistic picture of this feature accessing all these kind of information. Like let's say I should always know that my find friends feature is only accessing location and contacts information. It should never actually be accessing microphone information of the user. So these high level details are sometimes better than basic granular level details. So for that, you can again use your data access feature, data access attributing feature. What you could do is we can set up an attribution context and give a name to that attribution context. For example, here, I'm calling that as find friends. And then we can pass this to the callback, the ad ops callback that was set up. We can pass over this attribution context to that guy. And whenever you get a callback about a data access being conducted, you could extract that information out from the attribution tag and go ahead and send it to your analytics system or whatever tracking system you have to map each feature to what kind of permission was being accessed to the user. So hopefully this would help apps have a better idea, and developers have a better idea that, hey, these are the certain kind of data I have that is being accessed, and these are certain pieces of my code and certain pieces of my feature which are actually accessing this information. And it could help build better UX for us developers, whereby now you can clearly tell the user that this kind of permission was being accessed because you used the find friends feature. So you could also present data audits to the user itself using this, that when we accessed and why we access this kind of private data from your side. Okay, now let's talk about scope storage, something that's been, let's say, a lot of bone of contention when it was released in Android 10. And because before Android 10, there were two kinds of external storages, right? There you have an app storage and you have a shared storage inside your app. And before Android 10, if you said, I have permission to access storage, you could access anything on the shared storage of the user. And Android 10 was the first release which clamped down on this and introduced this scope storage model, which it said, hey, no, you cannot access everything on shared, and shared storage would be a distinction between media files and other documents, and other documents were off limits. Like you could only get access to the media files by default. And a lot of apps were not really ready to actually support this, because this, let's say this was lots of effort for them to migrate, and storage has constantly changed in the way storage works across Android versions. Like we first had the storage access framework, which changed a bit of details of about how storage works. Then came scoped storage. So app developers were not really ready to support that in Android 10. And back then there was an option to opt out by using request legacy storage field in the manifest. But in Android 11, that's no longer the case. Android 11 makes scope storage compulsory. So if you are planning to update the not planning, when you, like, it's a question of when and not if, right? So when you tend to update your target SDK version to 11, scope storage will be mandatory, and the request legacy external storage will not be respected on Android 11 devices with apps targeting Android 11. So what does this mean for us developers, right? There's a few little changes that have happened since scope storage was introduced in Android 10. First up, I would say the biggest one would be storage has been renamed to files and media. This is to make it more clearer to the user that it no longer would say that this app wants to access your storage. It would clearly say that it's going to access files and media information stored on your device. And with Android 11, the right to external storage and right to media storage does not grant you any additional write access. It will still only be restricted to media files. All right. And in Android 10, also, like for apps that supported scope storage in Android 10, and I'm not sure if people who've used Android 10 has come across these, because to be honest, let's say not a lot of apps had opted into scope storage in Android 10. But for apps that did, even if they wanted to edit files that did not belong to them, they had to seek permission on a per file basis. So this example, let's say you have an app, Google Photos, which wants to edit these few files that the user chose to edit, but Google Photos does not own these files, So at that point, Google Photos would need to request access to each file individually. And that wasn't a great user experience. So in Android 11, now you can batch requests to all kind of files in one go. So if the user selects 10 files, users will no longer be prompted with 10 pop-ups that, hey, grant access to file 1, file 2, file 3. You can just, the developer can choose to batch all of these requests in one dialog, and permission for all of these files will be granted in one go. Right. So here is how you would do it. So instead of having, like, it's a quick short snippet, instead of looping over all the files and asking permission for it one by one, we can create a list of file paths and fire off the permission for that to the user, and the user will be prompted with this dialog, and the user can choose to look at all the files, which all the files are we talking about, and then they can grant access to them. And once the permission has been granted, you can go ahead and take the requisite action. All right. In terms of file restrictions, so that was about media. In terms of file access restrictions, the flag for action open document tree actually no longer gives you access to the entire document tree as was the case on Android 10 and below. Now, if you use that, your file picker will not allow the user to pick files from the download folder or the Android data directory and Android OBB directories. So these directories are now off limits. And similarly, that if you try to open a document from, if you use this flag action open document to actually open a certain document and you trigger an intent with that, users no longer have access to, you will no longer have access to the Android data and OBB directories. In this case, you can still go ahead and open files that are inside the downloads folder. All right, but I think the Android team completely understand that there are certain apps which still need all kind of permissions, like exclusive access to, not exclusive, like full access to the user storage. Like if you're a file manager app, then in that case, these apps can still declare the manage external storage permission, which will grant them all files access. And for similarly, as we talked about other things in the past, that this is all based on a play policy guidelines that will be released. This should come out in the future as well. And again, like I would emphasize that I did try this out in a debug build, and if you're using a debug build, your manage external storage completely works. You don't need any play policy permissions for that. I am assuming that because it's debug and that cannot be distributed through the Google Play Store. But if you're building an app that you want to distribute, I would still, it would depend on the play policy guidelines that come out. And as long as developers continue to respect that policy, this should still be okay. So like the open source question that came up earlier, like if you have an open source app and users are compiling that and running it in debug mode on their phones, I would think that should be a go ahead, because when I tried that out locally as well, it continued to work. But when it's just, if the users wants to, if you want to distribute that open source app through Google Play Store, then probably yes, you would need to respect the policy guidelines that are released sometime in the future. All right, so those were the, let's say, the big important changes, but there are a few little tiny changes here and there as well, and I'll try to run through them quickly as well. There's fine-grained phone permissions. So earlier when you did a read phone state, Android 10 and below allowed you to get information about the phone state as well as phone numbers. In Android 11, that's restricted. Since phone states is generic information, you can get that, but phone numbers is private information for the user, so that gets restricted behind a new permission, which is a read phone numbers permission. If you declare that, then you can get access to line numbers that's needed. So Android, so to do that in the manifest, you can declare a max SDK version on your read phone state. And if you need phone numbers, you will need to add the read phone numbers permission, which is only for Android 11. Again, this takes place if your app targets Android 11. So if there's an existing app which is running on Android 11 and has not updated its target SDK yet, then read phone state will continue to give phone number permissions to the user, to the app. There are more restrictions introduced on MAC address. Now we can no longer access the MAC address for the network interfaces. They will continue to return zero. They will continue to return null. Currently, from my testing, it does not throw a security exception. So if you are handling nulls in your app, this should continue to work. And just like most of the changes that gets introduced, this is also gated behind the upgrade to target SDK. And there's another change to access system alert window permission. So earlier, so this is a very small change. What happens is earlier, if you were trying to request the system alert window permission, you could direct the user directly to your app where the system could toggle the permission for your app. But now you can no longer do that. You can only redirect the user to the generic list of apps which want this permission, and the user will explicitly have to open your app in the list and grant them the permission. So you can no longer deep link them directly to your app inside the system settings. And mind you, this applies, again, this is not gated behind SDK. So if you have an app running on Android 11 who's not yet updated to target Android 11, this behavior change will still apply. And okay, so that was a tour of all the settings that have all the new privacy changes that are in Android 11. Some are gated behind updating your target SDK. Some just apply as long as the user is on Android 11. So how do users prepare for these kind of changes? Like you might not want to, adapt to all the changes in one go and release one, a big bang release which like has all these new changes, because you would want to incrementally test them out and see, hey, do they continue to work on older devices as well properly? So for that, we have this new compatibility framework. So in developer settings, you would see a new app compatibility section, which allows you to select your app, and then you can selectively enable or disable these certain features, these certain privacy changes for your app. So you can say, hey, okay, enable auto reset permission for me, and auto reset my permission right now, and the system will do that. And then you can test what happens. Like given auto reset requires you to update to Android 11 as a target SDK, and you don't want to do it. You just want to test it out with keeping it target as Android 10 because you're testing. You can do that with the app compatibility. You'll just toggle that switch on, and this specific change will now be applied to your app. So this change, I really feel like this compatibility framework should really make adding support for Android 11 a lot easier. And if you're not a fan of UIs and you're a command line person and you want to use the command line to enable and disable these changes, there's ADB has support for this as well. So you can just go ahead and look at the Android documentation. There are new ADB commands which can enable and disable these feeds for you. The ADB commands also allow you to query to check what the current state is for your app. Oh, I actually had an example. I actually forgot about that. So you can see in this example, you can do that through the ADB command as well. All right. Just to quickly point out here, this new compatibility framework inside developer options is only applicable to debug apps. So right now, this option is so on the beta. So be it the beta build or the public user build, this test app compatibility changes will be available in the developer options. Just that for changes which are enforced as long as the user is on Android 11, irrespective of the target SDK of the app, those change features cannot be toggled if you are using a public build. So currently on the beta builds, you can also disable features. You can also test out features which do not require you to upgrade to Android 11. Change your target SDK to Android 11, you can also test them out. But once the public build is there on your device, you cannot do that. And next thing to note is this compatibility changes, you can only change the behavior for debuggable apps. So none of the release apps, like you cannot take a release app and try to change, apply certain features for them, even though they don't support Android 11 yet. Nope, it is only exclusively for debuggable apps. All right, yeah, that's it. To wrap up, a lot of privacy changes that have been introduced, but on the bright side, most of them don't take place until and unless we target the new SDK. Few behavior changes do take place. Most of the changes should actually not need any additional dev effort if the apps are already following the best practices. And that's something to keep in mind, I would say. Like from my personal opinion, I would say is to keep in mind for the future as well. Even more changes that would be introduced over the next couple of years on Android should keep in line if we are following best practices. That's just a hope. Don't take my word for it. I'm just hoping what happened with Android 11, that if the apps are following best practices, stuff like permission, scope storage don't really need a lot of changes. Hopefully that's the trend, keep moving forward. So continue to strive to follow the best practices as guidelines are laid out by Google. And developer options now has a new way to test these changes incrementally for you to make sure your apps are adapting properly. Yeah, that's it. Thank you for your time. And yeah, if you have any questions, feel free to ask. And there's my Twitter handle in case you don't want to ask any questions right now and you want to fire them on Twitter later. Yeah, go ahead and do so.
Okay, so if anyone has a question, you can just unmute yourself and yeah, start asking the question right away, or even put them in the chat.
Most of the things I see is about my presentation not working. Oh, no questions. Maybe it was really clear, or maybe nobody understood the thing.
No, now we are worried about that we have to do this on our apps and just sort of make all the changes.
I'm just hoping it's less changes for people in case they were already following all these practices. That's the hope.
Definitely, yes.
Saurabh, I have one question. It's not regarding to the new privacy changes in Android 11, but more sort of new way to request permission. So could you share little bit information about that? So exactly, I don't know what it is, but there's an easier way to deal with the runtime permission API. Are you aware about that?
If I recall correctly, I think you're probably hinting at the new activity result contract. Yeah,
Correct, yes,
so actually that's a part of the Jetpack framework. It's not really a part of Android 11, so that should work properly across all API version. What that does, like the way it makes it easier is you no longer have to deal with on activity results and you getting callbacks to on activity result and then calling your methods which does the job. So you can actually request the permission at the same place, get the call, have the callback code in the same section, and deal with it. So I think it's a bit difficult to talk about that without a code snippet, but the
yeah, that's fine. Yeah, we just wanted to know like what it will allow us to do. So I think more on the line like it's easier for a developer to request permission rather than dealing with complex API.
okay, I think I'm not getting it, but I'm not sure what you really meant by complex API.
So like if you see the runtime permission API, it's very confusing like uh, in terms of usage. The kind of result it returns like one-time permission granted or granted denied permanently. So to use that API, it's quite confusing. So this new API will allow developers to easily request permission.
I see. Okay, so what I would mention in that is, so the activity result, the new activity result contracts API actually has support for requesting for permissions inbuilt into it. So, and it has a bunch of other constants which allow you to do standard tasks out of the box. So stuff like if you want to take a picture or make a call, you can just use those one-line functions that have now been added. But if you're talking about permissions specifically, okay, so I played this with this a while back, and I don't really have it at the top of my head. But from what I remember is you would register just one callback and just fire off a request permissions for this new permission that's been granted to you. So instead of having to pass the intent data manually yourself, match the request code, that is it this request code, and what's the intent data type, like does it say permission has been granted, has the permission been denied, should you have a request rationale pop up? You don't really need to do all of this anymore. You would just be like, hey, I'm requesting this permission, and just call my individual callbacks depending on what the user state is. Don't get me to parse all the intent information and figure out how I'm supposed to react. So let's say just took away a lot of this boilerplate away from devs, the repetitive code, and just abstracted all of that away for us and just offered us simple callbacks to handle this.
So
Right,
instead
that's
of
what I wanted to know. Like,
yeah, Sagar. Saurabh, I
that's what
wanted
I
to add
wanted to know.
something. So you are saying that in on activity results, like you would see that method, pile up. Like a lot of developers handle all their changes there, right? So instead of that, you have this new contract which you can use and make the code much more concise.
Correct. So, because you would every time an on activity result, you would keep on checking, hey, is my request code this? Well, is it the request code for my permission? Result code is for what is the result code? What is the request code? Did the permission get granted? Did the permission get failed? Did one permission get granted, but the user denied another two permissions? All this code no longer needs to pile up.
Right. So I think that's gonna make life much more easier now.
Yes, definitely.
Yeah, that's what I wanted to know. Like this API, is there anything else that this new API allow us to do, or is just for for developer to make their life simpler to request permissions?
Yeah, it's mostly targeted to make life simpler. There is, from what I recall, there's nothing in this API, this new KTX library that we couldn't do earlier. You could do them, but just the steps and the ways to do it earlier was a lot more verbose, and now it's a lot more easier. And it's not just actually targeted towards permissions, it's anything which needed activity result callback. So let's say you wanted to fire off an implicit intent to take permissions. Oh, sorry, to implicit intent to ask the user to take a image, right? What would happen in that scenario is you would send an implicit intent to take an image, then you would get a callback, you would check your request code if it's the image request code, you would check the result code to make sure that it was a success, then you would unmarshal the intent data. It returned you a byte, right? So you would convert it to a bitmap, and now you have an image. But with the activity results contract, you could just go ahead and say, just start an activity, which, and my contract is take picture. That's it.
Oh, I see.
So you're done with taking a picture, you get a callback with the bitmap directly. So you don't need to unmarshal intent or do anything about it.
Okay, so it's not permission specific, it could be anything. Got it.
Yes, basically look at it that it's trying to cover scenarios which require you to start activities for result.
Awesome, thanks. Yeah.
Right.
Someone in the chat asked about how deep links will behave.
It can do in with respect to.
Yeah. For example, I have an email. So there will be a particular link to open the particular page of my app from email.
Okay.
So technically, it is like a different app, right? So that email app or the SMS app has to handle anything different for this deep link to open my app.
No. So what the only thing for them is user behavior if you want to avoid the disintegration dialog.
Okay.
So like if an email app with a link which will open your app, what happens sometimes is that if you tap on that link, the system will present a dialog saying, oh, multiple apps found that can handle this link, let's say Chrome browser and this app. So do you want to select this app or do you want to select the browser? So if the SMS app wants to avoid that, they can use the new intent flag, which is require non-browser, to actually do that. But that's on the part of the requesting app, not on your app side. You wouldn't be able to really avoid that disambiguation dialog from your side.
Got it. Yeah, thanks.
Great. So we had one more question by Bhargav in the chat. So he asked from Android 10 Go device. I think he has no permission for system overlay. I think he asked if there is no permission for system overlay in Android 10 Go device. So is there any alternative for supporting Android Go devices?
Unfortunately, no. Uh, we we've had this in the past as well. Even actually, even I was supporting Android Go devices in the past, and there wasn't any workaround for this available back then. I don't think anything has changed because currently the idea is to clamp down further on system overlay permissions with the introduction of bubbles in Android 11, and which was a part of the developer previews in Android 10. Um, that's becoming the new pattern for if you need to draw overlays on top of the screen. That's becoming the new pattern to go forward in Android 10. So eventually, I don't think you'll have access to that.
Yeah, I'm having the same problem as well. I use system overlay in my app, and I tried out the Bubbles API, but it doesn't really sort for my use case. So right now, all Android Go devices are off limits, and I'm thinking in the next couple of years I'll have to deprecate my app completely.
Yeah, Faiz, I know your app, what you're talking about.
Yeah.
I think it's a primary use case for you. Without
Because my
that,
app is completely useless without the permission.
yeah.
Yeah.
Actually, conversation with Genymotion to see if I can integrate into the emulator somehow.
Oh, wow.
Yeah.
Maybe you could approach somebody on the Android team as well. That would be a great integration.
I spoke to someone. They're like, I don't know, we don't have any answer for you as such. You just tough it out until your app can run, and then goodbye.
I mean, another not a suggestion, another thought I had the last time I heard this, that this is going to bite you, was in case you want to open this out as an SDK.
Yeah, I know. I've had a couple of people asking for it as an SDK, but then the whole idea behind it has been that developers can just set the values in the XML files. But for designers, for product managers who want to overlay, there's no way to access these values, and my app was kind of there to bridge that gap.
Yeah.
As a developer, if you're setting an 8 dp margin, you know it's going to be 8 dp. But as a designer or a product manager looking at an app, you don't know what that size is until you actually open up the lens.
Mm-hmm.
So maybe SDK is a route, but not too sure. It'll lose the purpose of what I built it for.
No, cannot comment. Yeah, I think we have another question in the chat. Your app should not request access to background location. For the question about background location there, that what if my app needs background location and system is, and the Google Play policy is that if you don't really need it, remove it. Actually, that's the thing. That's the fine line, right? I mean, I can't comment on Google Play policies here about what do we do if accessing background location is a necessary thing. Because at least from my understanding, I feel like if you're accessing background location, it is still possible if you're doing the proper pattern which has been described, that you first need to access for foreground, then you need access, then you request access for background, and for background access permission grant should be explicit by the user, that there's no in-app option to say allow all the time. The user will be pushed off out of the app into the system settings, and there they can select. So I feel like if the system continues to allow explicit grant and your app has a valid use case, I think it should be okay. I mean, again, I'm not the best person to comment on this, right? It's a Google Play policy. But my hunch for this would be, if you are following the policy and there's a valid use case, it probably should be okay.
Right. So yeah, I guess that's the end of the questions. Any more questions from anyone?
Okay, I think we've covered it up, Saurabh.
All right.
So yeah, thanks for joining us. Thanks for taking out time and talking about privacy changes in detail. This was very informative.
All right. Thank you so much for having me. I had a great time. It was really fun. I
Yes,
think this was my first time speaking in front of an Indian audience though, since I moved to Singapore. So I actually really loved it.
oh wow, didn't know about that. So so this is like your first talk in an Indian audience, right?
Correct. Like it's mostly been around the Singapore side. So Malaysia, Indonesia, Singapore, Vietnam, Thailand. Like this has been most of it for the last 1-2 years.
Wow, that's nice, and it's good to have you here. Hope to see you in more talks in communities around India.
Definitely. I really look forward to that. That's something I've been wanting to do for like a year now. So I'm really glad this turned out well with you guys. Like really, really appreciated having me over.